Hey, how's it going? My name's Parker Howell, and I'm here today for my final project in BA 513, Information Technology and Data Analytics. What I did my project on in association with the coronavirus data was really ultimately comparing the difference between the numbers in Germany and the United States. A little background on why I chose this topic. I'm really interested to move to Germany. I've been born and raised in the United States, actually Nashville, Tennessee, and I've always had an itch for German culture and lifestyle. And now that I'm graduating with my undergrad in engineering, mechanical engineering, and then my master's in business, I really want to move over there for a few years and begin working. Uh, Something I'm near and dear to my heart. So as soon as we were assigned a project with some of the coronavirus statistics, especially in the way that Germany has been handling the situation, I thought, well, that would be a perfect opportunity to compare. The country I was born and raised in, and the country I aspire to go to here soon. So, kicking it off, where I posed a few questions, which is what led me into diving into the data, was where is each country in terms of the timetable in eliminating the virus? So where are we in phasing it out? Obviously, different countries are in front of others, and just where is Germany in relation to the U.S. or vice versa? Then which led into, does the total number of cases correlate with the scale of population? Obviously, it's a big concern comparing two countries that are um, different in size, to say the least. The U.S. has probably 4 times as many people in Germany. Germany is obviously a much smaller land area, but I was curious on that, and then that leads into which country's done a better job mitigating the effects in terms of mortality rate. So, how many of the cases that have been confirmed have eventually led to death? So, let's dive in. All right, starting off, this is the traditional curve that you're going to see when someone's giving you the likelihood of the lifespan of COVID-19. So this is the curve. When you hear the term flatten the curve, it's really pertaining to this top part. It's really trying to keep the peak as low as it can without rising too high. Clearly, I have the peak marked here. The max number of confirmed cases in a day was 6,900 in Germany, which seems like a lot in relation to the population under it. 83 million really is not a ton. But you can get a good idea for the curve. And this last date right here, this is as of the end of April. So obviously we're a couple weeks ahead now. But in relation to see where they are, you can see the curve has a general nature of kind of escalating quickly and then rising a little slower. But it does have that distinct drop in number of cases per day. It's really where it's phasing out of its hold on in hospitals, and the spread is really getting contained. So in this visual, you can see, clear peak rising down, and they're really on the back end of it. You know, as of April 30th, they had only 1,400 new cases in comparison to the almost 7,000 they had only a month before. So as you can see, it phased out pretty good, and it seems to be on that track. Now comparing that to US's chart, it's a little more skewed. You don't see that clear curve that you do from the line in Germany, uh, but you do kind of see where we would have hypothetically peaked. As you can see, our top number of cases that we brought in per day was 36,000, which is a little higher than the 7,000 in Germany, but also you have to consider population as a part of that. But looking at it, you can tell we are in a very different phase than Germany is. They are clearly on the descending part where the virus is working its way out of society. But as you can see, we're still almost right at our top number of cases. As of April 30th, we were, 30, almost 30,000 cases. So a little different. Where obviously it's interesting because it almost seems like a plateau. in terms of statistical terminology, this is kind of what you hear when you hear flatten the curve. It seems like we have flattened the curve, and it seems like we're descending, but it seems like it's almost we've combined it into a step, and it seems like that's in the transition phase we're in. There's not a clear peak. It really just looks more like a, I don't know, top of a castle, and then like it's probably progressing back down as you progress. So as you can see, a lot different curve in relation to where we are in the lifetime of the virus. We are just now starting to kick it, which can be scary. But as you saw on the chart before, that was a good month from the peak to where they were really descending back down into the what would be on this graph 5 to 10,000 range. So as of this last date, you could probably predict we're maybe a month behind, maybe a little more, maybe a little less. It's kind of hard to justify off one set of data. But off of those, you can kind of see that the United States is behind Germany in this sense. So that answers the first question. But now moving into total number of cases, I really wanted to look into how the population correlated with the number of cases total. You hear a lot about urban density, and that's really something I wanted to look into, but there was not a lot of statistical data from Germany. You kind of saw more of that from the United States end, so I kind of had to work with what I got in terms of looking at numbers for the whole country. So looking at Germany first, you can kind of see this curve. It takes that normal progressive up, and then it starts to, you can see it increases in number, but it starts to decrease in the rate, which is very apparent in the almost S-shaped sideways curve here. They have a total of 163,000 cases, which in relation to the population, it's only 0.19% out of the almost 84 million in Germany. So that really is pretty good. It didn't really hit too hard. You can conclude what you want, and then comparing that to the U.S., we obviously are just over 1 million cases by the end of April out of our 340 million. That affected 0.31%. So you have a difference in 0.12% there, which may not seem like a lot, but if you're going to relate that 0.12% to the American public, that's over 400,000 cases alone. So really that 0.12% difference makes a large difference in terms of how big this actually becomes in the U.S. Because if you can take off 400,000 off of that 1 million, you're getting down to 600,000. You're cutting out almost half of the cases that are experienced, or at least confirmed. So that in itself, reflects the correlation in population and the reach of this virus. Clearly, it's made a bigger impact in the U.S. Now, there's obviously an array of reasons why, but I think that from this data, you can see the slight correlation in population to how many actually attract the virus. But then moving into deaths. Now, what does this virus actually do when you contract it? What is the mortality rate? And that's ultimately how effective the virus can be gauged. And starting with Germany, another clear curve. There's obviously variance in the curve, but there is a distinct curve where you have a peak at 510 deaths on April 15th was their high, but the second biggest to them was, it just was not even near, maybe half that. So as you can see, a clear curve. They're clearly on the other side of it in a decline. 510 really is not a ton. But then looking at that compared to the U.S. curve, you can see we're still almost rising. If you had to add a trend line in this, it's still increasing. Now it's hard to say how this curve carried past that April 30th date. But again, you can see the distinct peak at 2,600 deaths in a day, which is pretty substantial, but that was April 29th, which is the second to last date this was even available. And then a week and a half earlier, you almost hit the same number in another 2,600 deaths. So as you can see, the death statistics in the U.S. are again pretty shaky in comparison to Germany's. It almost seems like it's a plateau, which is very uncharacteristic of traditional curves for this virus, which actually begins to call into question a lot of the data that is getting collected and brought in from the United States. What's considered a confirmed case, what's considered confirmed death or coronavirus death. It's a lot of things that have been in the question in the last few weeks. And I know it's something that they've been trying to change at the beginning of May month. So a lot of this data may be, affected by cases that may not have been lethal or may not have even had a part in killing people that actually were factored in to keep this. But still, you can still see this increase, which plays into our timetable. We're just getting the other side of this thing. But then now we go into looking at total deaths, and this is something that was interesting to me because this is ultimately testing the effectiveness, the effectiveness of the policies and really just the mitigation techniques that are put in place by our bureaucratic leaders. Social distancing, lockdown, shutting down business, and it really comes out into the effectiveness. How the resources that we're able to allocate to hospitals for proper treatment, anything, and being able to treat, diagnose, test the whole spectrum. It comes down to mortality rate. You're trying to save lives, and through this graphic, as you can see, Germany, the mortality rate is 4.06%. And that is really good in compared to other countries. That's almost as good as it comes. In the U.S., you see we're right at that 5.89% mark. So almost a 2% difference, which it makes a lot. Now, the U.S. and its size and its population, we've really done a good job of keeping that number kind of low for what it could have been. I mean, obviously predictions on the forefront of this were astronomically higher than what we're seeing. But still, we're talking about life or death situations, and seeing this mortality rate difference shows the effectiveness of some of the things we have put in place. And I know that, the ultimate goal is to be effective and to save as many lives as you can. And obviously that's ideal, and that's not ever going to be perfect. But I think that this can almost put into perspective some of the things that we're going through and some of the things that other countries are going through the same way, and the responses and what is the correct and best way to handle it. What does that mean going forward? So with all these statistics coming in, what did you learn from this presentation? Well, first, you learned that Germany's ahead of us. Germany's probably a month ahead in terms of their phasing out. And you also learn that they've been a lot more effective in terms of not spreading it to the population, and then when it spread, ultimately not killing the patients. So given the fact that they are ahead of us timetable-wise, they have been more effective, I think it's important for us as American citizens to really not take notes, but really just to be aware of what other countries are doing that are working. Techniques and strategies that are working in other places than here, because this is a global issue. This isn't just one issue that any country's facing, and it's really something that we have to get over together as a human, as humanity. It was really I really enjoyed this project. I enjoyed diving into the data. I had issues uploading other data sets, so I had to create all my visuals, which was a little tough, but at the same time, you really get to learn a lot about, the ins and outs of Tableau and really the ins and outs of the data of something that's affecting everyone's lives. So I hope you learned a lot from the presentation, and thank you so much for everything in this class, and good luck the rest of the way in this coronavirus stuff. Thank you.